Hi, my name is Thomas Kim. This session continues from our previous session using directive versus include directive. This is our previous video. If you haven't watched this video, please watch it. In this session, we will learn the difference between managed type and unmanaged type, and the difference between pointer and tracking handle, and the difference between stack semantic versus heap semantic. Please note that I am using Visual Studio Enterprise 2017. I will create an empty solution, other project type solution, here, O3, managed versus unmanaged solution. Click OK. Right click, add new project, select CLR console application 01, managed versus unmanaged. Click OK. Here at this file, namespace talk play fun, and here using namespace talk play fun like this. Now here I'm creating a classic unmanaged class. Say this is unmanaged class. Okay, unmanaged class, or is called, or it is also called native or classic C++ class. Okay, and here please watch it, REF class, managed class. So this is managed class or CLI or CLR class. CLI stands for Common Language Infrastructure. What CLR stands for Common Language Runtime. Okay, I will use CLI or CLR interchangeable. They are not actually the same, but I will just say, I will call them interchangeably. Okay, so this managed class is declared with REF class, and unmanaged class is, this is classic class, classic C++ class is just declared class managed. Okay, so the difference is REF. Here I declare public, and I declare int mi. This is member field. Also here public int mi, member field. Now we will see how we can use these two classes together. So here first we start with stack semantic. Stack semantic. It means we allocate or declare or define local variable on the stack frame. Okay, so in this case, if we are using stack semantic, then unmanaged class you see we can declare like this. Also at the same time, managed class MC. These are stack semantics. Okay, so we can display std cout uc mi uc mi std and there, and I declare one. This is managed class, so it should be MC like this. To use standard out, we have to include IO stream. Okay, now save. If we run it, Control F5. Please note that you see unmanaged class by default. In this case, it is not initialized, and managed class MC's field member MI is initialized. Okay, so you have to be careful. Things like this. If we want to initialize it, uninitialized unmanaged class object. Okay, unmanaged local variable. If we want to, if we want to initialize with the default values, then unmanaged class, say it initialize with default value, initialize with default value. Okay, then in this case we can modify like this. This is UC1. Okay, it will be initialized, and it will not be initialized, and it will be initialized. So Control F5. So you see UCMI. In this case, it is uninitialized. We introducing this curly brace, then it gets initialized. The member field is initialized, and in this case, it is initialized by default. Okay, so you can also do the same thing here. Managed class MC1. Then the result is the same. This will be initialized. Okay, by default managed class managed objects are initialized. Okay, also we can explicitly initialize managed objects with default values with this syntax. So I will copy this one once again here. MC1. Okay, now let's run it once again. Okay, I hope you understand the difference. So far this is stack semantic. Now we are using heap. Heap or unmanaged heap, and managed heap semantic. Okay, heap semantic. In this case, in case of managed class, unmanaged class, we are creating pointer p uc new unmanaged. We can uninitialized allocation on unmanaged heap. I will create one more unmanaged class puc2 new unmanaged class initialized allocation on unmanaged heap with default. Okay, so in this case, in case of unmanaged heap semantic, now we are turning managed heap semantic. Okay, in this case, managed, we have to use tracking handler HMC. We have to use the gcnew managed class. Okay, this is actually by default initialized with defaults. Default means default value. Managed class HMC2 gcnew managed class initialize with default value. Okay, now let's run std cout p. We are starting with this one puc mi puc mi std, and we copy this puc2 and we copy once again. This is HMC and we copy once again HMC2. Okay, please note that we have, in case of unmanaged, this is pointer, is type pointer to an instance of unmanaged class. Okay, this type is called tracking handler or just handler. Okay, managed heap semantic is also called reference semantic. Okay, so please compare. This is stack semantic. Okay, stack semantic, and this is called reference semantic. Okay, This is called reference semantic. So in case of a pointer, classic pointer, we have to delete PUC like this. We also have to delete PUC2. But in case of managed handle, we let garbage collector reclaim the managed heap. Okay, so in case of managed handle, this is handle not pointer. We don't do this. We don't usually do this. delete HMC. We don't do this usually, and also we don't do this. Delete HMC2. Okay, so now let's run it. Because garbage collector collects the memory used. Okay, also garbage collector collects managed heap, the memory from managed heap. Now save it. Now let's run. Ctrl F5. Now everything works as expected like this. Okay. So in this session we learned the managed type, unmanaged type, and managed type. Unmanaged type means classic C++ class, and managed type means REF class. Okay, and the pointer, we use pointer to dynamically allocate memory on the heap, on the C++ heap. Why is called unmanaged heap? We use tracking handle. Pointer is usually used operator like this, and tracking handle uses head operator. We use tracking handle to dynamically allocate memory on the CLR managed heap. So we learned these two differences, and we also learned the stack semantic and heap semantic. In case of stack semantic, REF class managed class, if we define like this, in local function, in local scope, if we declare managed class MC, we declare like this. This is stack semantic. And if we dynamically allocate, for example, managed class HMC gcnew managed class, if we declare like this, this is called reference semantic. Reference semantic actually means dynamic. Semantic means dynamic dynamic allocation under managed heap. Okay, so we learned the difference between stack semantic and heap semantic. In the next session, we will talk more about stack semantic and heap semantic or reference semantic. Thank you for watching.